Okay, so once again you are mostly welcome. Now we are again in for item 015. We are back again on our mathematics revision series, and now for this one we have a special one, by the way. A special one in a way that in here, please, we have the topic is scatter graphs. And now if you look at the syllabus, please, scatter graphs were only examined in A level only, but the new curriculum, in fact the new curriculum brought it forward here. Okay, so we have what we call scatter graphs. It is a new topic, and please, I beg that you watch it to the end because you never know. And now scatter graphs, they are examined in they can be examined on any item depending. However, the scatter graphs are under ratios and proportions, that is the area of construct 1, so they can be set on item 1. I beg you watch this to the end such that you don't miss out the new changes or the new topics in the new curriculum. Of course, you realize that some topics like set theory were there back then even in old curriculum, but this one here of scatter graphs is a special one, in fact one of a kind, so be there for it, watch up to the end. All right, good. Let's go and see what does a scatter diagram look like before we go there. In fact, just want to show you a picture here of what this looks like. All right, so that's how a scatter diagram looks like. If you really don't know how to do it, then better keep on the video such that you can really benefit. Okay, good. Without wasting time, let's go and see how that comes about in the run. All right, good. So I simply remind you to subscribe to the channel. Please, we remind you to subscribe to the channel. That really helps us a lot and keeps us going. In fact, the only appreciation we want from you is that subscribe and hit the notification button. Okay, without wasting time, I think let's start off. Right, good. So straight to the question. That's our question. Let's go through it slowly. Get some letter pen here. All right, great. So they're saying Maria, a surveyor, okay, I think a land surveyor by the way, embarks on a journey from Mukono to Kampala construction site anyway to perform crucial soil testing, as the soil's sand content plays a critical role in ensuring foundation stability and preventing potential settlement or foundation failure due to excessive sand. All right, good. Maria's journey begins with a 30-kilometer stretch on a bearing. All right, so now I think this, always be careful with this. They can bring what you call a 2-in-1. Like in here we have bearing and we have scatter graphs. All right, please, this video I've said it is a nice one. In fact, better watch it to the end. Okay, on a bearing of 080 degrees to Kalagi. All right, let's start off with the sketching of this. With bearing, you need to sketch. So they're saying a bearing of 30 kilometers on a bearing of 080 to Kalagi. Where shall we get that sketch of ours? Allow me just, okay, where shall we get that sketch of ours, by the way? Where shall we get that sketch of ours? I think, let me just have this sketch right here. I'll have it right here. So assuming that's how we have begun, we begin with that and put north. Please, you can check in the playlist. We have a full topic of bearings. Did you want to check in the playlist? We have UCE bearing. The topic is there explained at length. Okay, so we have that as north. Now it's beginning from where? 30 kilometers on a bearing of this to Kalagi. Now remember, in the beginning they said that embarks on a journey from Mukono. So she started from Mukono and she's going to Kampala. So here she started from Mukono. Allow me call it letter M. Letter M. Mukono at which degree, at which angle? At 080. So 080 is between there, like that. So you must show with this that this is what we have as 080. Please, it is right there. Now it extends up the side. Now in front here is where we shall put our Kalagi. You can, I'm just getting a sketch. We shall have the accurate one. That is north. All right, good. Now what must we know? Now from Kalagi, let's proceed. The saying followed by a 330-degree turn. A 330 degrees. Now 330 will be this kind of turn to that level. So the line will be drawn onto this, going in that order. 330 degrees turn to what? and a 40-kilometer drive to Gayaza. So in front here we have what we call what? In fact, whenever you're drawing, you should put there north. So in front there we have there our Gayaza. So you remember, in this very start here we had, this very start here we had 30 kilometers. Now next here we have what? We have, in fact, we have 40. We have 40 kilometers. Okay. I have 40 kilometers right there. Just, I want us to get a sketch of this. Okay, now we have ended at Gayaza. Okay, now finally, she heads on a bearing of 250 degrees. And, okay, so when she's here again, she goes for 250 degrees. So 250 degrees will be around right there. In fact, 250 degrees will be around there. And it will go like that. To which place in front this side? Now here it is 32 kilometers. That's what I have there. Please don't forget a north there. We shall get a clear diagram here. I just want us to see a sketch. Okay, 250 and 30 kilometers to reach construction site in Kampala. So that is Kampala. Okay. Upon arrival, she collects soil samples at various depths and records the sand content percentage in the table below. So this is the soil sample depth. And the so she was collecting different areas. At first, the soil sample depth was 36, percentage of sand was 86, 65 percentage of sand was 70, 55 percentage of sand was 80. So she was sampling different depths. Now, like this is the piece of land, she can pick here, pick there at different depths. Then she looks at the percentage of sand. Now, you think the kind of sketch you are meant to have there. Now, okay, good. So that, let's proceed. Now, these are the values we have. So we proceed. They're saying Maria needs to create an appropriate graph to visualize the relationship between depth and sand. Okay, now a graph which talks about two things which are changing, depth and sand which are changing. Okay, and calculate the total cost of surveying materials, including 50 meters of measuring tape at Uganda shillings 10,000, 20 soil sampling bags at Uganda shillings 5,000 each, and fuel, in fact. Alright, and fuel at Uganda shillings 6,000 per kilometer that she traveled. She will submit the calculations to apply for funding from her company. Good. Part A. Help Maria draw a precise diagram illustrating her journey, including bearings and distances. Now, here talking about bearings and distances, meaning that they will need our sketch. Part B. Develop a scatter plot or scatter graph to illustrate the relationship between the depth and sand content, aiding Maria in her data analysis. Number 3, describe the relationship between soil depth and percentage and sand percentage, including any trends or pattern you observe. Alright, good. Now finally the saying, plot a line of best fit through the scatter diagram and use it to predict the sand percentage at depth 131 centimeters. Estimate depth at which sand percentage is 51%. Lastly, assist Maria in preparing a budget proposal to fund her project activities, including her return trip to Mukono via same route. So it means that Maria had to use the same route in the long run. Like, she moved from here, up there, back there, and down. So she must go back in that very route there. Okay, good. Now what must you know here? Let's start off with part A. They're saying, help Maria draw a precise diagram illustrating her journey, including bearings and distances. Now remember, you all know how I got that sketch up there. Let's go and have it accurately this time round. Okay, so you're answering part A, we say. So you begin by giving us a title, a sketch diagram showing Maria's journey from Mukono to Kampala. So please, all we need from you is first of all a title. Now let's get our sketch. She began with Mukono. That's what we have. In fact, she began with that, so we have that north. Okay, that is Mukono. M is meaning Mukono. There it was 80 degrees. Now in front we had Kalagi, that's 300 kilometers. We are drawing our sketch. So here we're going to have our Kalagi. Please, the way I'm drawing is the way you're meant to draw. So that is our Kalagi. I'm calling it K. The next we measured a bearing of 300 degrees. Okay, M means Mukono, K means Kalagi, G means Gayaza, and KL means Kampala. So those letters, if you see them there, just know they mean that. So you measure 360. Okay, and with that we say that is 300 degrees. Then we have our line drawn. Please just know that this is drawn in this way. All right, now what you must know is that if you have a bearing, say for example north like this, if you have to measure 300 degrees, we start from here like that and we'll go partly there. That's how it moves. So this one is moving in that order. That's how we're measuring. Please, if this is really disturbing, you can go in the playlist. We have a full video about bearings, or at the end of this video I'm going to put you a full lesson of all the videos concerning bearings, and you'll be there to enjoy them. So at the end of this video you will see a pop-up of a video about bearings. Okay, now we have that at 300. Then this is 400 kilometers. The next day we have what we call Gayaza. That's Gayaza. Don't forget any up there. So that is our Gayaza. Now at Gayaza we're going to measure 200 degrees Celsius, not Celsius but 200 degrees, sorry. So we have that, and then we draw a line to where the marking ends, and that has been what? Okay, we go now to Kampala straight away, and I put the labelings. That's north till 32 kilometers, and that's 250 degrees. Okay, good. Now that has been a sketch. Then we must know how to convert here. Please, it is a 2-in-1. Our last step is going to be a scatter graph. We must know how to convert this into centimeters, by the way. So we say scale conversion. Scale conversion, let's see. So let 1 centimeter represent 5 kilometers, and that shall have that, shall have that, shall have that. Okay, that's part A. So it means what? It means that if you say 1 centimeter represents 5 kilometers, this is what you divide by every distance right here. So the 30 divided by 5, we have it right there. It's giving us a 6. The 40 divided by 5, we have it right here, and it has giving us 8. 32 divided by 5, we have it right there, and it's giving us 6.4. Then from there we shall move straight to drawing the accurate diagram that should be done on a graph, part B. So to an accurate diagram, please, we shall refer to the sketch. So we are begin with the Mukono, back to Kalagi, to Gayaza, and finally Kampala. Let's do that. What do you have here? We have M 80 degrees 30 kilometers, which is 6 centimeters. Let's do that. To start with, okay, we need the title still, we shall say. And actually today I'm showing Maria's journey from Mukono to Kampala. We always need a title here, so let's begin with the Kalagi as per the sketch. That's oh, sorry, this is part B. Maybe just erase this off. Oh, anyway, still part A. Sorry, still part A. So now we have our Kalagi being drawn down here. We have it there now. In that Kalagi, what must you know? We must measure 080 degrees. Where will it be? From the north. So from the north, like that, that's our 80 degrees, and that is our 6. Now here, as I'm drawing this line, I must measure the 6 centimeters from here up to there. I've said you can watch the video, full video about bearings. We have it there in the playlist, so that you can know what we are trying to mean here. So we shall put our 80 degrees there. We shall put our, that is our Mukono. Okay, then we shall have another town in front. That is now we are going to Kalagi, right there. So you have that name. Do you have that north is needed? That north also. Now when you're right there, we have to measure 300 degrees like that, and once you have a diagram like this, this is north. Remember, this is 90 plus 90, 180 plus 90 to 70. So a 300 degrees will be around this area here, and that's how I shall have it. So let's see next. So that has been 6 centimeters from the conversions. Originally it was 30 kilometers, but now we have 6 centimeters. Now let's see how we can draw the 300 degrees right there. I've explained that is Kalagi. So that's how the 300 degrees are. So the curve shows in a different way, but you must measure going in that direction like that. Like that. Then we draw the line. 300 degrees, a line is there right away. And now the distance of that line, please, the distance of that line is was 40 kilometers, which we converted and we got 80. kilometers, and that pushes us up to Gayaza. So that is now our Gayaza coming on right there. So this here we use a protractor in measuring this. Right, good. So that's our 8 centimeters. Okay, that's our Gayaza. Now at Gayaza we must now measure 250 degrees right there. Let's see how that can be measured. We have that. Then you do a line stretch away. Please, I've told you to start from north clockwise. So we have that. And how much was it? Remember, this would have had 32 kilometers and gave us a 6.4 kilometers. So that will be 250 degrees for the angle and 6.4 centimeters. And with this, we shall now get the last town, which was our Kampala, like that. So that's our Kampala in simple terms. So that is our north. All right, good. I hope that has made some sense. Please, if you want to see how bearing is done, you can check in the playlist. In fact, not even playlist, but I'm going to put it for you at the end of this video. With that, let's proceed. So part A is done. They only wanted us to show on the graph. So let's go and see what part B needs. So part B, they're saying, develop a scatter plot to illustrate the relationship between the depth and sand content aiding Maria in her data. So they want a scatter plot. When you see this word scatter, it means a scatter diagram. How do you plot a scatter diagram, by the way? Okay. How do you plot a scatter diagram? Let's go there. That's part B, Roman number 1. How do you sketch a scatter diagram? Okay. Now finally, you need to, first of all, come around. Okay. Very good. Okay. Now, let's see how a scatter diagram is drawn in simple terms. How is a scatter diagram drawn? Let's begin by first of all labeling our axes. Labeling our axes, we get them ready. We are beginning by labeling our axes, we get them ready for work. Labeling our axes, we get them ready for work. Please, the sketch use matters a lot. And of course here, I'll transfer them here such that we can all make a follow up. Transfer them here so that you can all make a follow up. All right, as that is coming by, let's be getting some ink here. We get this done here. So we get a table here. We get a table which you have the other side. Transfer it for you here so that you can all follow. Now what you must know is that, allow me put here letter X and allow me put here letter Y. Okay, good. So now here, originally we have 35 and 86. That's what we have. Next we have 65 and 70 right there. Next we have a 55. I will sample for these ones, then the rest you will be going about them. 84. One sample for a few ones, then the rest you can live with them. You have a 25 and 92. 25 and 92, like that. Then we have a 45 and 79. Okay, I'll put these ones. Yes, please, the values I'm talking of here, the values I'm talking of here are the ones we have in the table. The values I'm talking of here are the ones we have in the table. And of course, now what you're going to do here is, in simple terms, start plotting. Let's start plotting. Now you realize that now at 35 you begin by plotting the values you have in the table. Please, I'm trying to bring the table forward. So 35 on x-axis and 36 on y. So 35. Now understand my scale. My scale is like this. That here we have a 10, 20. Here we have a 30. So it's 35. It means that one small square equals to 2 units. That is it. So if you want a 5, I'll count like something. So if this is a 30, okay, up to here 34, 32, 34. So 35 will be right here in this column. Now 34 on x, 35 on x, and 86 on y. So you must move right in this. What is 86? 86 is right there. So the first point must be plotted around there. Okay, good. Another one is 65, 70, 65 on x. So x-axis is this. By the way, I didn't label this. Let's get this axis labeled. Okay, now that is our x-axis. I think now we are together. So 65 on x-axis and 70 on y. So where is 60? 60 is here now. 60 is 70. So 65, you come some 3 lines from here. 1, 2, 65 is around in this area here. Put a marking for you. 65 is around there now. What you're going to do, plot against 70. So for that very line up to 70, that very line up to 70, it will be somewhere there. Another marking. Okay, 55 on x and 84 on y. 55, where are you? 55, we have this. 1, 2, 3, here we are. On what? On 84. So move upwards in that lane. 84, where are you? 84 will be somewhere right here. That's where the another point will be. Now another one will be 25, 92. 25, 92, where are you? 25, 92, where are you? 25 is 20 is here, so 25 is midway here. 92, move up, 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 up. This 90, 91, 92. This is good to know your scale very well. That's what another point will be. Now realize that here, if you have from 0, here we have from 0 to 10. So it means that every one small square here represents 1, like say 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that is it. So each has 1. On the vertical, mean that on the vertical axis, one small square represents 1 unit. On the horizontal axis, right for here, one small square represents 2 units. That is what we are doing with here. You can write that around this corner here to show the examiners that you know what you're doing. Okay. Now let's move on still. Let's move on. Now what does it mean? We have now plotted that, so we plot 45, 79. 45, where are you? 45, okay, I've already plotted that. Now, you do that the rest of the values, and you keep on plotting. Now realize that these values here, in fact, let's just add them here. Alright, another one is 75 and 68. 75, where are you? Oh, this one we repeated. By the way, here we meant to have a 70, sorry. We meant to have a 70 there. So, now what is a 70? 75 will be around here, and the what? And 68. So, up, 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 up. 60 is here, 66 is here, so 68 will be around there. Okay, another point is what? Let's have 20, 26. 20 around there, and what? And 96, by the way. And 96. So, let's calculate that. 20 is right here. 96, where you move up, 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 up. 96 in this very line here, like that. That's what the marking is, and that's like about the plotting. So next one is a 90, 58. A 90, 58. Now where is 90? 90 is right here. 58, where are you? Just move up, up, up. 50 is here. 56, 57, 58. It will just be right there, like that. Now having done that, what I meant to do next, another point is 51, 86. In fact, it's 51. Write it for you here. 51, 86. Now 86. So 51 on x, where is it? 50. 51 now 86. Where are you? Upwards. 86 upwards. Where are you? Here we are, and just right here, midway this point here. That's what shall be. Now all what you're seeing there are dots. Now lastly, let's have this. We have 60. 60 again is 77. So we have 60 again is 77. Please, I'm taking the values which you had in the table originally. 60 again is 77. So 60 on x, 77 on y, 77. It will be right there. Now I think how those points are scattered. You don't have any order. Like all level, when you're plotting, you can either plot and get a curve, which you can join like that. You can either plot and get a straight line. That is it. So when you have that, it means that this is the curve, this is a straight line. But now here, what can you see really? I think that these points here are scattered. This one is on its own, on its own, on its own, on its own, on its own. I don't have an order. So we call this one as scattered points, and hence the name scatter. Okay, graph. Now, what must you do next? Here, you must come out to find out color x bar and y bar coordinates. How do you get x bar and y bar? You go about adding all x values, like 35 plus, we have them up there, 65 plus the rest, divide by how many are they, maybe they are 10, then you give us that answer right there. Do the same for y. You will add 86 plus 70 plus other points there, divide by 10, you give us that value. Now you'll make a coordinate of x bar, y bar. Now that coordinate is also plotted in here, x bar, y bar. And of course, what you must know is that when you try to plot these points here, what you get as your x bar and y bar will be, okay, in fact x bar is, okay, get right here. In fact x bar is going to be 55, roughly 55. When you add all the x values, divide by the number which is 10, you get 55. When you divide all the y values, divide by the number which is 10, you get a 70. In fact, simply 80, like that. Now you must plot these two. Remember, this one is for x, this one is for y. Bar means finding mean. Okay, so now we have, say, x, we have what? X, we have 55. So let's go there. Where is 55 on x? 50 is here, so 55 is midway. Then chase for 80 upwards, it is around this point here, that point here, that marking you have seen. Now that's our midi, or our mini point. Now that mini point there is what you should use. Make sure that you do a line which passes through that mini point there and leaves equal lines on both sides. How shall we get that done? So you can draw, you make sure that you do a line all through this, pass through that, like that, like that. Now this line must be leaving out equal intervals. Like, say for example, if you count 1, 2, the parallel points 3, 4. Even this side you have 1, 2, 3, 4, 5. Okay, did balance all that, but that's what you are meant to do. I think we go and step into the magic. Alright, great. Alright, good. Let's see. Okay, proceed. So this one will give us, it will give us, erase this off. So we're going to have the points plotted. I think I've already explained, so here we shall be going straight to the point. We do the plotting. So we had, that's our title, a scatter graph. In fact, we have our title right there, a scatter graph. We must always write a title, please. Any graph work, we must always write a title. So we have our title there, saying a scatter graph showing variation of pressure, in fact variation of percentage of sand, y with the soil depth, x. That's how I chose to state it. Now before we go to, let's go into the plotting. So we plot the first point right there. I've already explained how the plotting is done, so let's begin again right there. I've explained how the plotting is done. Let's be getting them right there. I've explained how. Now I see that they are scattered. Now maybe I take it back for you. Now look, we have a first point there, another one is there down, and then the third one goes up. I see how it is scattered. Then another one goes again up. I see how it is scattered. I hope you see that. Now again the other side doesn't have any way it is organized. Alright, so I think you can see that. Okay, another one there. I think they are scattered down, up, down, up. Okay, now that's our mini point maybe, but I think how they are scattered. Now they are not organized, so that's why I call it a scatter graph. But of course, anyway, before I go to that, or having reached there, let's go and see here something we left out. Okay, okay, something we left out here. All right, let's go there. Go back there. Alright, good. So this means that alright, so now with this we want to see how the mean value is got. Let's see how the mean value is got. So the mean value is got like that. Like I said, we add and get the values. We add and get the values. That's how that one was gotten. You add all the x values and divide by the number. Now where is that 10 coming from? One would ask, where is that 10 coming from? You simply count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why I divided by 10 and have that as a coordinate like that. Now the y value also you add and do the same. These are the values you have in the table. Divide by 10 and you have 79.6. Then you report your x bar, y bar. Now why are you saying x bar, y bar? Because you find that in your statistics, this word here, x bar, means mean. So that's why I'm using x bar. That's why we call it a mean value. In simple terms, that's why we call it a mean value. Now this is what we are plotting. 51.9, 55.1, 79.6. And now since this is red ink is what we are plotting here as our red ink here, right here. Okay, so that's what we have as our red ink right here. Alright, now that's what we have as our red ink right there. Now to do a line of best fit, we must make sure that line of best fit. Now you're doing a line of best fit. Line of best fit must always pass through that red line there. Now let's make sure that we do a line which passes through this via that. Maybe may touch that point like that. Now we must make sure that your line of best fit leaves equal points this side and equal points this side. Let's see. We have 1, 2, 3, 4. Alright, how about this side? There are 5. Oh, sorry. However, now let's see the clear one, if it will come out. Let's see. However, even if it's not balancing, you can leave it. You don't stress yourself. Because remember, in the next exam, you're always chasing time. Let's do our line of best fit. Line of best fit is that's what line it passes through that mini point there. So let's see. So that's how our line of best fit comes. Okay, now it's not a must that line of best fit must touch another point. It can just pass through that red line only, that red dot. Now what does it mean? It means that here, look, let's count. That's our line of best fit passing through the mean. But make sure that this line of best fit leaves equal points this side. Like here, how many are they? Sorry, I'll erase this off. Like here, how many are they? How many are they? Like here. How many are they? They are 5. Okay. How about the side? Let's count them. How many are they together with this? Back there. How many are they? 1, 2, 3. They are also 5. So I see that the ones remaining on either side, the plotted points remaining on either side of the line, they must be equal on both sides in order for it to consider that as a line of best fit. So this one here is a line of best fit. Hope that makes some sense. Hope that makes some sense. Okay, good. Now with that, we have that covered. Now remember, they gave us some questions still. They gave us some questions. Then they were asking, okay, if you went back in the video, you realize that they were asking us that at 51%, what will be the depth at? They were asking for depth at 51%. That is depth like that. In our question, if you try to wind back the video, they were asking depth at 51%. Then also depth, in fact here 51% is okay like that. So what will be the x at 51%? That is it. Then also at 34 centimeters, that is the depth. They are like asking what will be the percentage at 34. So let's start with 34 first of all. There now 34 on x, what is it? This is 20, this is 30, 34 will be right here. So 34 here, what you're going to do, dotted line is upwards, dotted line is upwards. Where it touches the line, you do like that. Then you read for us a percentage. Remember, these ones here are in percentage, these ones here are in centimeters, of course, depth. Hope that makes some sense. So allow me to resolve this off, and we have that drawn. So we shall show from there. That's where our 32 is. Dotted line up where it meets the line. We draw a horizontal line to touch this vertical axis like that. Slowly. And after that, you must read a value right in that very position. You must read a value right here. You must read a value right here. And that value is, let's see. Now the arrow goes like that. So the value is, when you read keenly, that value there will be, in fact, 97%. So that means that when the depth was 34 centimeters, comma, the value of y was 97%. You have correctly answered that. Then also they asked, this was the first point. Then another one was, they were saying that, what about at 51%? At 51%, okay, what would be the value of what? What will be the value of x at 51%? Now it means that 51% is on the vertical axis, so we can locate 51. 51, where are you? It is around here. So dotted line again, like that, up to where it touches the graph, then downwards, the value we want. That's what we're going to do here. And allow me clear this off. Get this. Alright, good. Get this cleared. Alright, good. Now let's see that how that is done. So dotted line is up to where it touches the curve, then downwards. Okay, we shall have to read that point down there. It's what we need. So that point down there, which will be that point, you shall have it as you must understand the scale, by the way. And that one will give us simply 72 centimeters. So here the x, so the x is equal to 72 centimeters. So that's what she will find out. And I think let's have that in writing straight away. Okay, let's have that in writing. So when y was equal to y is equal to 97% and x is equal to 72 centimeters, I've explained those two things. With that, let's move to the next part. That is part C, which required a budget proposal for all the things done by. Alright, so let's go. Now you're right there, but we need something here. We need to analyze something here, and we wind up, please. We're about to wind up here. Alright, good. So now let's go back first of all. Okay. Alright, good. Let me get this. Okay. Now maybe I'll just read you part C. I'll just read you there has been a network error. I told you this GeoShare software we use. GeoShare software we use, sometimes the network disturbs. However, that can't really stop us. That can't really stop us. So let's move on. The next part. So we'll go there. Now we just read the part C. They were saying assist Maria in preparing the budget proposal to fund her project activities, including her return trip to Mukono in the same time. Okay, good. Now, but before we do that, remember somewhere they gave us this. I'll just remind you maybe. Before we go to that calculation, remember somewhere that given us that. Okay, allow me to use this area. That's given us that. What she will buy. In fact, they were giving us what she was meant to buy. So in fact, here she was meant to buy. If you check in the question, she was meant to buy a measuring tape at Uganda shillings 10,000. That is it. The next she had also to buy she had to buy 20 soil sampling bags. We had to buy 20 bags for sampling, and each bag was at 5,000. Now does it mean here the total will be that 5,000 times the 20 to give us that total there, and that will be 100,000. If that really makes some sense to you. The next also they were giving us that they were charging 60,000 shillings, 6,000 shillings per kilometer, like that. And I think with that, let's get this here and we see. So at first we say total cost, distance moved is equal to that. Now the distance moved is equal to that, and then we convert it to kilometers. Now what does it mean? It means that when you go back in this graph, here, please, when you try to add, forget this. Okay, sorry. In fact, we are meant to use the other. When you go back on the graph, remember our sketch was like this, back there, and back there. Please, I'll just give you a sketch here. The software, this stuff does it a bit. And now this one here was Mukono, this one here was Kalagi, this one here was Gayaza, this one here was Kampala. I was calling KL. So they want the journey, because we want to calculate the amount of fuel she used. So we want this journey here, from here up to there you add, from here up here you add, from here up here you add. But remember, this one here had 6, this one here had 8, this one here had 6.4, if you can remember. So you're adding a 6 plus 8 plus 6.4, that will be in centimeters. Then you multiply by 5, which can take it back to kilometers. Okay, let's go back. And now that's what we have here. Total distance is equal to 6 plus 8 plus 6.4, and have 20.4 centimeters. Then multiply by 5 to convert to kilometers. Okay, good. Now that means that to get total cost, remember 1 kilometer costs 6,000. So you multiply this by this to get total cost as far as transport is concerned. However, that's part C. Let's begin with measuring tape was for 10,000, nothing much. Then sampling tape was shillings 20. There were 20 of them, but each was at 5,000. So you multiply. I've explained that. So we have fuel, which will be shillings 6,000 times. Now here I'm applying this by that. The 6,000 for fuel, total distance here you get 609,000. Okay, to get a total you add this plus this. In fact, the total will be 609,000 plus 10,000 plus okay 100,000, and guess the total. Shall have that as our total, like that. So total cost is shillings 719,000. As simple as that. That marks the end. But please, I'm really apologizing for the network error this time round. I think, in fact, it has rained today, so I think that's why the network was disturbing. Anyway, I would beg to end there. Thank you very much. For whoever subscribed, this is for you. For whoever subscribed, this is for you from me. That's my face to you. Whoever subscribed to this channel, we request and call for your continuous support. Keep sharing. I'm really happy with you guys. Now, what you must know is that at the end of this video here, I'm going to put for you a bearing as a topic, a full topic. Be ready to watch it. Nice time. Thank you.